Hello friends, this is lesson 15 of NLP, Natural Language Processing. In today's lesson we are going to cover the following topics. First we'll be discussing extraction information from text, and then information extraction architecture, chunking, Engram feature extraction, and then we'll see how to create a new chunker. Now let's start with the first topic in C, extraction information from text. So friends, here converting unstructured data or text into structured data and finding the relationship between the entities, right, described in the text is called information extraction. So from this definition you can easily understand that the first step is what we have to do is converting unstructured data to structured data and then identifying the entities and relationship between the entities. This process is called as extraction information. And you know better that whenever we are reading the text from maybe from the web or from the desk, that text is called raw text and it is not ready for computation and it is not ready for modeling. So what we have to do, the first step is to do some pre-processing steps, and they are called like text normalization if you remember in previous lectures. So we have to convert them to a form that is ready for computation and modeling. So that is nothing but converting unstructured data or text into structured data and then identifying the entities and relationship between the entities. So the process called as extraction information. Now let's see what is unstructured data. So in unstructured data, it has no repeating pattern, right? And approximately here 70 to 80% of data around us is nothing but unstructured data. Example for them, we have the data which comes from social media. Emails are examples of unstructured data. Text is an example of unstructured data, right? They are not ready for computation. We have to do some text normalization or pre-processing. And then what is structured data then? Structured data has a defined repeating pattern. So if it is defined repeating pattern, it means it is easier to sort. It is easier to read or load the data and also process the data, analyze the data, and the whole process is faster compared to unstructured data. Now let's see the examples here. The examples, we have normalized text. If you remember in text normalization we had some steps like we had to convert all the text to lowercase, remove the punctuations, tokenize them and streaming, all those things. So after that the text becomes structured data and that is called normalized text. And tag text, when we say tag text, it means the words with its parts of speech, right? And that is nothing but normalized text. And in whole we can say structured data. Now let's see here, the second topic is information extraction architecture. What are the steps we have to follow here for information extraction? So the first step is loading the data, which is called raw text or document, or reading it, right? And then what we have to do is splitting into sentences, and after that splitting into tokens, and then we have to assign the parts of speech or tagging parts of speech. The next step is entity recognition and finding the relationship between the entities. So these are the steps which are nothing but the architecture of information extraction. Now let's see, the next topic is chunking. What is chunking? It is actually a technique used for entity recognition by segmenting and labeling the tokens and selecting a subset of tokens. So after cleaning the text or normalizing the text, the next step is entity recognition. So this entity recognition and labeling them is nothing but chunking, and we have the following two steps there. First of all, segmenting means splitting or identifying the chunks, and after that what we have to do is labeling, assigning the correct tag to them, and that is called labeling. Then we have Engram feature extraction. And one thing you have to remember, friends, up to now what we discussed is nothing but grammar based approach or tagging what we say. There in grammar based approach we will be identifying the tokens or entities, and then we'll be assigning the parts of speech according to that, and that is not that much helpful. It is not always working, and it is not flexible. Here we have examples for that, then you can better understand. Instead of that, if we go for another approach which is called context based approach, which plays a huge role in conveying the meaning and phrases. Let's see this two sentences here we have. The first sentence is she liked the smell of roses, and the second one is she smelled like roses. This is taken from the book. And here, friends, if we go and find the frequency of each token, or which is called back of words, and we find the vector for them, they are having both the same back of words. According to this grammar based approach, they are both the same. Actually, if we go to their meaning, they are completely different in meanings, right? Because here we have she, here also we have she, we have like verb, here also we have smell is there and smell is here. These things will be removed, right? And this is the noun. The back of words of these two sentences are nothing but same, but with different meanings. So it means instead of going for grammar based approach, it is to go for context based approach. And you know the reason, and this is an example for that. Now for doing that, we will go for something called Engram. So what is Engram? It constitutes the basic non-recursive phrases corresponding to the major content word parts of speech. Now it means here we will not consider only a single word or a single token like this. Instead of that, we will be combining 2 or 3 tokens together, maybe 2, maybe 3, maybe 4, like that, and that is nothing but considered as phrase. Like we will be considering noun phrases, verb phrases, adjective phrases, and then preposition phrases, like that. Like if you remember here, if it is grammar based, so this is considered as a single token, this is considered as another token, and this one is considered as another token, grammar based. But if we go for Engram, here we will be considering like 2, like this, 2 or 3 of them as a single token, or as a single phrase. We can we call it as a noun phrase or verb phrase or adjective phrase. Now here let's see example is given, then you can better understand here. What is n here in Engram? N is nothing but a number, and it means if it is equal to 1, that is called unigram. In unigram, what we have here, one by one it will be considered. Like here that article is considered, then this one is considered, this one is considered. One by one it will be tokenized and will be considered. If n is equal to 2, that is called bigram, and bigram will be creating this phrase. This is the single phrase, this is the second phrase, and from here, again from here to here it is another phrase, and from here to here we will be having another phrase, right? If it is trigram, right, and trigram means we will be considering 3 words as a single phrase, like this. The man took, and again from here to here it will be considered as a second, and from here again to here 3 words will be considered as a single phrase. Now let's see here, creating a new chunk. Now if you are doing this type of chunking, so here we are able to create our own chunk. Means our own chunker will be using regular expressions, and you know regular expressions are used for searching in text, if you remember the definition from previous lectures, or it is an algebraic notation for characterizing a set of strings. Now what we have to do, we'll be creating our own pattern. For example, we don't want like this one by one. We are creating our own pattern. We say, for example, noun phrase. In noun phrase, I say first you check for minor or article 1 or 0. So means question mark means 0 or 1, at least 1 or 0. Then followed by any number of adjectives. Star means any number of adjectives. And then followed by noun, maybe 1 or 0. See here, this pattern is nothing but it is helping for extracting my own information from the text, what I want, right? So phrase, and this is possible using regular expressions. You will be creating your own chunk, or instead of that you can create another like you want, and here we will be searching for any number of adjectives, then followed by any number of nouns, and then plus concatenation is here. Then you check for if there is any preposition, then again it means you are creating your own chunker and your own type of extraction the feature from the text, what type of text or data you want to extract. And then here, this you have to remember, friends, we'll be calling a function from NLTK, and that function regular expression parser, and you give the name of your pattern, what you have specified here, as an argument, and that will be creating you a new chunker. And then using your chunker, you can parse here, or you can tag your tokens according to this one. To this one, you can tag the document, and then you can print the result or draw the result. Let me show you all these things practically, friends, here, then you can better understand. First, we discussed about extraction information from text, and there we talked about converting unstructured text into structured data and find the entities and their relationship between the entities, right? And then we talked about information extraction here, architecture. This is the architecture, friends. What is the first step? The first step is loading the text or reading the text, and that is converted into sentences to tokens, then assigning the parts of speech, and then entity recognition, and finding the relationship between the entities, right? Now let me apply this here. This text is taken from bbc.com, so we'll be considering this text as an input or our document, right? Let me execute this part, and now let's see the second step. What we have to do is we have to import these two libraries, execute this part also, and then here we have chunking. What I say, I will create a function called information extraction, and I will be passing a document to this function. So according to this architecture, what we have to do, the first step is to split it. Now I'm doing that here. I will take the document and I will be splitting it into sentences using NLTK predefined function sent underscore here tokenize. So the document will be split it into sentences. Then we have to do, what we have to do is we'll right. So that I have done here. The sentences will be considered one by one the words, and they are tokenized. And at the same way, what I am doing, I will check whether it is punctuation or not. If it is not, then you tokenize it, right? And the next will be assigning the parts of speech here or tagging. So for that I am using again a predefined function from NLTK pose underscore tag, and the tags will be, the tokens will be one, the parts of speech. It means whether it is noun, pronoun, adjective or what, and the result will be returned. And come to see the result, I am calling my function and providing the document BBC News, and let me print first 20 rows and see whether it is tagging or not. Yeah, it is tagging. You see, it says it is noun, and this one is its modal verb, be is a verb. See, like that it is assigning the parts of speech for that. Now let's see here, creating a new chunk. So for creating a new chapter, I said we'll be using regular expression function called regular expression parser, and we have to provide a pattern. I will create the noun phrases. It means determiner 1 or 0, followed by any number of adjectives, then followed by maybe 1 or 0 noun. Let me comment this one, right? Okay, I will execute this. So the chunker is created. Now this sentence as a document, for example, the small white house near the beach. So first what we have to do, we have to tokenize it, and then here I will assign the parts of speech, whether you can do it this one or you will be using your chunker here. See, this is my chunker. I will use my chunker with assigning one more. Let me see the result here, and we'll print the result. Yeah, friends, this is the sentence and this is my noun phrase. And noun phrase, you see the article, then followed by any number of adjectives. How many adjectives are there? Here we have 2 adjectives, small and white. So as I said here, followed by any number of adjectives, then followed by noun, and the noun for me here is house. So the whole thing will be considered as a single phrase is my noun phrase. And then see the second noun phrase which is created. Again we have the article and then followed by noun. Adjective was not there. So according to this pattern, it is recognizing and printing for me here. And now let's draw the result, and here also you can better understand by seeing the figure. Let me zoom it. Yeah. So see friends, the then followed by any number of adjectives according to this article is there, and then 2 adjectives are there followed by noun, and this is my first. Second noun phrase is again we have the article and then followed by adjective was not there, so followed by noun. This, so that is a preposition, right? Okay friends, I hope you understood this much. Now let's talk about the Engram feature extraction. In Engram, I told you whenever n is equal to 1, it is called unigram. If it is equal to 2, it means bigram. If it is equal to 3, it is called trigram. Let me show you here practically. I am reading my text, BBC News, and by default, if you are not passing to this function any number which gram we want, so it will be printing for us bigram. But here if you say I want unigram, so the n value I am changing here, it will be showing me unigram. In unigram, I told you 1 by 1 the tokens will be considered like this. If it is equal to 2, means this is called bigram, right? This is called bigram. If it is equal to 3, so this is called trigram. See, we may be, again it is starting from the second token, may be and banding, and again it is starting from this token. As I showed you here, like what it will be doing, these 3 will be considered first, and then again these 3 will be considered second time, and third time these 3 will be considered. So this, and now train, test and evaluate Engram taggers. How can we do that? Let me show you one by one. First I will show you unigram tagger. So for unigram, what we have to do, first of all, I will be like I'm calling my function here, and this function will be splitting the document into sentences, then tokens, and then it will assign the parts of speech to that, and then we will be getting tag tokens, right? And then after that I will be splitting the data into 2 partitions, 50% for training and 50% for testing the data, right? Let me do that. Yeah, now I will train my tagger using here unigram tagger. It is a predefined function, right? I create my object here. I say unigram is equal to NLTK.unigram, and here I am providing training data. It means this one, right? Let me execute this part. Yeah, and then here I will be using my unigram object, and through that I'm calling a function called tag. right? Tag. And then I will read some data of news and let me see whether it is tagging or not. Yeah, you see friends, it is tagging. It is tagging correctly. Since see some of them are not tagged, it is showing me. Why? Because the data or the number of features are less. The data what we provide is here like 50%, and also here the document is less. If we have more number of tokens, so it will be considering each and every word, so that this also will be included. Right? Some of them are none. And now let's see and evaluate here. You can see, yeah, it is around 45%, we can say. And now if it is bigram, you will be calling another function, tagger, right? In the same we have, yeah, it is trained, and let me see whether it is printing or not. Yeah, you see it is doing that. And again we have, see the accuracy should be less because these things are not like assigned parts of speech. And you see now here, yeah, this is the evaluation. And now let's see if it is trigram, you will be calling this function, the same, I'm training it, and then let's see whether it is assigning. Yeah, it is assigning, but still it is not trained fully because the number of features are less, these things are not identified. And now let's see to evaluate them. This is the evaluation result. And lastly, we will be combining multiple taggers, friends. Like we have tagger 1, tagger 2 and tagger 3, right? And that's called unigram, bigram and trigram. What I am going to do here, whenever I am training my first tagger or unigram, so the backup for that I will be choosing from this one, default tagger. It means if there is like this, any word is not tagged, what you consider that as a noun, and that will be used as a backup for this one. And then I am calling my another function bigram, and the backup for that will be tagger 1, and I am calling another function trigram, and the backup for that will be tagger 2. And then here I will assign and test my evaluate my tagger 3, and let's see the result here. You see the accuracy is increasing 55 because these things are also covered. If they are not assigned the parts of speech, they will be considered as a noun, but still it is not accurate because of less number of features. If we have more number of features, so we will be creating a good and better one tagger. So I hope you understood all these things, friends. We talked about these topics, and I hope you understood. We said how to like extraction information from text, and then we talked about information extraction architecture, I showed you, and then chunking, creating a new chunker, and also we talked about Engram feature extraction. Thank you, friends.